Hey everybody, this is Can't Stop the Unk, and this is Going Over Arrays Part 2. So what you should notice is that once you create your array, you can always change it and manipulate it, and you can just overwrite everything in the array if you want, right? So now you might be wondering, well, what if I don't want to overwrite it? I just want a copy of it, right? You want to change the array, but you don't want to lose your original, so you want to just copy. So first I'm going to teach you the right way to copy an array. Now what's happening is when you have your copy array, right? You're going through the for loop and you're basically sending its value from 0 through 99 for each iteration through the for loop, right? And for each iteration, you're aligning it with the array, with your original array that you have called arrayInt, right? So arrayInt index 0 when you go through the first time in the for loop. So this is going to be 0 the first time in the for loop, right? And this is going to be index 0. So at index 0 for the copy, you're going to have the value of the arrayInt at index 0, right? And then when you go through the next iteration of the for loop, it's going to be 1 to 1, and it's going to go 2 to 2, right? This is why you use the I for both of these inside the bracket, so that they're corresponding to each other when you iterate through the for loop. And this is how you create an actual copy of the array. So now you have two separate arrays, right, that have the same elements, right? So I emphasize the word, they're separate from each other, right? So now I'm going to show you the wrong way to copy an array. What you might think is that you can just create an array copy like this, right? You have your integer and your bracket, so you want an array, and you put your variable name, and you just set it equal to the original array, right? So this might look like an easy way and a pretty logical way to copy an array, but they're not going to be separate arrays, right? What they're going to be is two variables of the same array. So basically, remember what I told you, when you say new int size of array, Java allocates memory for that array. So what you're doing is this array copy variable is just referring back to the same memory that's been allocated to arrayInt, right? You're not creating a separate new memory location. They're actually just referencing the same memory. And what I mean by memory is just pretend that it's somewhere in your computer, there's memory in it, and Java it's just a place to store stuff in, right? That's basically how you should think of it. And these two variables are representing that specific storage space, right? They're not referring to separate storage spaces. So what happens is, if you wanted two separate arrays, look what happens. I'm just going to change arrayInt, right? I'm not doing anything to the copy, right? I'm just going to change arrayInt index 99 and set its value to 0, right? Remember, we set its value to 1,000 earlier, right here, right? So we're going to change it and set it to 0. And what you should expect is that the array copy at index 99 should still have 1,000, because we did nothing to it. We didn't change it or do anything, right? There's no line of code. But this arrayInt, the original array, should have the value of 0. But when you print it out, you'll see that arrayInt and its copy have a value of 0. And this is because, like I said before, those two variables are representing the same storage space, right, in your computer memory. So when you change arrayInt, you're also changing array copy, right? So this is why it's called the wrong way to copy an array. If you want two separate arrays, right, this is the wrong way to do it. You need to allocate memory. So when you go back and look at the right way to copy an array right here, you'll see that what I did was I allocated new space for the real copy, right? Now, real copy, this variable name, has a separate store space from the original array. They represent two different things in the computer memory. So now when you copy the array like this, now you're storing each element value in the new storage space, so that when you manipulate it, right, when I print it out again, now they're both 0, right? Because obviously the real copy and arrayInt, they're copies of each other. But now when I change the specific element in the original array called arrayInt and set it to -100, right, and I print out real copy and array int, you'll see that they're not both effective like it was earlier when I created the fake copy. So basically, the lesson is, I know there's a lot of words in there and it might have been confusing, but basically what you need to get is that you can't just simply set a value equal to something because you didn't create new space for it, right? What you want to do when you copy arrays, you want to create new and a different storage space than the original. Then you copy each element over, and now you have two separate arrays that you can manipulate on your own. So that's basically what you need to get, and then if you just look over this code and think about it, you should be able to get it. And the last thing I want to go over really quickly is how double array works. Technically, you can put as many arrays you want, but in order to understand how like higher dimension arrays work, I guess, all you need to know is how 2D array works, and you pretty much can figure out how 3D array works and whatever. So I call it 2D arrays or double arrays, basically same thing. So the way the syntax works is that you declare your primitive type as usual. So it could be string int. So I'm using int, and then instead of putting the one pair of brackets, you put two pairs of brackets, right? So that's pretty logical. And now Java knows that you want a 2D array of ints, and you have your variable name, which I call double array. And then you have the syntax again with your keyword new int. And then instead of putting one bracket, you have two brackets, right? And you want to fill out the dimension, right? So if you want a 10 by 5 2D array, then you just put 10 by 5. Now, what you want to remember is which way does it go first? Like, does it go left to right first, or does it go top to bottom, bottom to top? Which direction does it create the array, right? So I'm gonna show you what happens when you print it out real quick. So when you put 10 for your first bracket, it goes from top to bottom, okay? It starts from the top and it goes on its way down. That's how your 1D array works, actually. So when you just print out one array, what you should think of it is actually a list that goes from top to bottom. And then when you put your second part of the bracket, it goes from left to right, okay? So just remember the ordering, and because it can matter in some situations. So just know that. Now what I'm telling you when I say double array or 2D array, I'm telling you to visualize it kind of like this, right? Kind of like a matrix, all right? Like kind of like this right here. But what it is in actual, like what it actually is, it's an array of arrays, right? So you have your first array, right, which holds 10 integers, right? And each element in that array holds another array, right, that holds 5 integers, okay? So that's what it actually is. It's an array of arrays, okay? So it's a list of things that holds a list of things, basically. But for visualization purposes, when you first work with like double arrays, it's usually easier to think of as a 2D array. So that's why I introduced it this way. But just note that it actually is an array of arrays. Okay, so if you can understand that language that I just spoke, that means you pretty much have arrays down, at least for 2D arrays and higher level arrays. Because this concept becomes really useful if you want to think of 4 arrays or like 5D arrays, right? You can't really picture 5 dimensions, right? So what you want to do is think of, it's an array that holds an array that holds an array for how many dimensions you have. And the way you fill it out is as follows. So this, instead of using one for loop, you need a double for loop. So what you do is you have your standard for loop syntax like this. Int 0, you have your integer counter, then your condition, and then your increment, right? But when you do the second for loop, the inner for loop, you want to make sure that you use double array and you pick an index, right? You pick the index and then you use the dot length operator, right? Because like if I didn't have this, right, this length would go up to 10 actually, right? This double array dot length is referring to this length, the first array length, right? So it's 10, but we know that we only allocated space for 5 right here, right? Because we're in the inner part of the for loop, so that means it's referring to the second part of the array, right? The array of arrays. So this is 10, and we don't want that because we know we only allocated space for 5. So you got to put 0, right? This is where the array of array concept comes in handy. Is that we access the first element of the original top array, right? And then we get its length. That's how we know it's 5, right? Because it's an array of arrays. So we're grabbing the first element right here of this first array, and then we get the length, right? So this is the first element, so we grab the length of the array, so that's 5. And that's why you want to have some index. It doesn't matter if it's like 1 or 2 in this case. So we just put the length, and then we set every value in the 2D array matrix to be equal to 10. And that's basically how you work with 2D arrays. And it's the same for 3D arrays and like any dimensions higher than that. So that's it for this video. There's a lot of information here. I know arrays may seem a little complicated, but once you work with them, they're not that bad. And this is part where like things get more interesting and you start feeling like a programmer. So it's probably gonna take more time to work out the concepts, which is fine. Just keep working through them. You'll get it. And I hope to see you soon for lesson 4. Thanks.